Okay. I think we can start for today. Okay. So, good morning, good afternoon, good night, everyone, and thanks for joining this webinar, which is part of the Technical Talks of CTSoc series. This is the 12th webinar organized over the last, let's say, year and a half. So 24 speakers already joined for this initiative, which was organized by IEEE Consumer Technology Society. And in particular, this is an initiative which is organized by the technical activities area, which is a rather new area, just been created just some years ago. And within this technical activities area, there are what we call the technical committees. The organization of the area is like this. There's a technical committee board, which is responsible for managing the activities of these technical committees. The chair of this board is myself. I'm also serving as a VP Technical Activities. I'm Fabrizio Lamberti. Starting this year, we do have a vice chair, Cheng Hong Dixon Lin, which I thank for accepting to serve as vice chair. The other role in these boards are the president, the new president, Fabrice Labeau from Canada, VP conferences for the Beman from USA, VP publication Norbert Heringsar from uh, Czech Republic, and Michael Condry, VP Industry and Standard Activities from US. This technical activities area is also participated by the officers, chairs, vice chairs, and secretaries of the 15 technical committees that, as you can see, are representing broadly the areas of interest of Consumer Technology Society. Today, we have mainly two technical committees represented. The CCN, which is the acronym of Consumer Communication Networks and Connectivity, and the SPC, which is Security and Privacy of Consumer Electronic Hardware and Software System, with their
So then
former or current officers. Here you have a list.
Okay, super. That will be good. That will really be good. Yeah.
Well, here you have a list of, please silent the mic, please. Here you have a list of the current officers for all the technical committees. They are doing a great job, so I'm happy to see some of them connected today. Each of these technical committees has its own web page with the mission, with the list of members, with license positions and stuff like that. Maybe if you are attending today, you are a member already of these technical committees. If not, there is a membership application form that everyone can fill in, and then the officers will screen the applications and will check whether the new potential members can join our technical committees. This is a current distribution of some members across the various technical committees. We have about 1,100 members already admitted, but we have about 300 new applications pending that has to be processed. So our community is growing very quickly. And why being a member of the technical committee? So technical committees are expected to help CTSoc in all the areas, conferences, publication, standards, education, history, in many ways. Some examples. So basically, the technical committees are here to provide opportunities to members and reward members for their activities. And some of the examples in which the technical committees have helped CTSoc are they are involved in covering the technical positions in CTSoc conferences like ICC Las Vegas, ICC Berlin, Gaming, Entertainment, Media Conference, and stuff like that. The technical committees are identifying people that will become associate editors for our journals, Transaction, Consumer Electronics, and Consumer Electronic Magazine. They are organizing special sections in journals. They are organizing workshops, conferences. They are helping with the number of initiatives that we are carrying out within IEEE and with other societies like SPS, AES, and stuff like that. They are launching special interest groups. They are selected as distinguished lecturers. 4 out of the 6 distinguished lecturers of CTSoc these years come from the technical committees. They are involved in talks like this one. They are have the possibility to get funded projects. This year we had 2 student internship projects funded. They're working on the implementation of standards, the development of standards, and stuff like that. There are other initiatives revolving around consumer technology society, like the digital reality, in which there are a number of other societies involved, like Reliability Society, EPS, EMBS, CRFID, Standard Association, Robotics and Automation Societies, etc. So one of the initiatives that has been launched by the technical activities is the Technical Talk series. So a series of talks in which every month or every 2 months, speakers from 2 different technical committees join, like today, for illustrating their specific research activities, giving a talk, an interesting talk. Today, the floor will be for Professor Tomu Murase and for Dr. Serena Merat, who are representing 2 different technical committees, as I said. I would stop here because I would leave the floor to my colleagues who will manage the rest of this talk. About a 15-20-minute talk for each of the speakers, and then a Q&A, either after each speech or at the end of the presentation. So I want to thank you for attending. I want to thank the 2 speakers for being with us today. And I will stop the presentation. I will leave the floor to the colleagues for introducing the speakers. Here you have the link to the technical activities area of CTSoc in case you are interested. Thanks again. Dixon?
Yes, okay. Thank you for your introducing the technical talks. So the first speaker is Professor Tsutomu Marase, and he is a member of CCN+TC CTSoc. He received his master's degree in engineering science and a PhD degree in information science and technology. All are from Osaka University, Japan. He is currently a professor in Nagoya University. He has been engaged in research on QoS, quality of service control, and traffic management for high quality and high-speed internet. His current interests include wireless network QoS control, MAC, and transport and session layer traffic control and network security. He has many journal papers and conference papers in addition to more than 90 registered patents, including some international patents than domestic. He is a secretary of IEEE Communication Society Japan chapter. He is a member of IEEE and a fellow of the Institute of Electronics and Information and Communication Engineer, Japan. So the title of this talk, he will give the talk of entitled of User Cooperative Mobility for Better Communication Quality. Let us welcome his speech.
Thank you, Dixon. Can you hear me?
Yes, I can.
Okay.
Yeah.
Thank you for joining this my talk. Okay, I'd like. Okay, let me share my screen. Yeah.
Yes,
Is this okay?
we can see your screen now.
Okay. Thank you. Okay. I'd like to introduce user cooperative mobility, the new paradigm of network control method for high communication quality. User cooperative mobility, user cooperate with internet operators or telecommunication carriers for better communication quality with lower cost. I'd like to start at the background of user cooperative mobility. Yeah, no, we need the internet anytime and anyway. The wireless LAN network and Wi-Fi technology give us high quality communication ways. Now, more attractive applications require internet, especially high-speed internet, such as IoT or driving applications requires continuous and high-speed internet. Many of them requires some assist of mobile edge computing. So to access mobile edge computing, we need more high-speed access network. We currently have 5th generation high-speed network, 5G. However, 5G and 6G, beyond 5G or 6G, uses higher frequency radio. So cover area of 5G is very small. 5G of the one base station of 5G is very smaller. Within the cover area, the terminal have enough high speed, but without the cover area, they cannot have. So aspect of carrier business, it might be harder to settle many base stations. To solve the smaller cover area problem, 5G architecture includes D2D communication model, device to device communication model. In the model, terminal connects other terminals to directly communicate to each other. Then the connected terminal forms merge-hop network. This merge-hop network is formed as ad hoc manner, so this can be called ad hoc network. We can use several Wi-Fi technologies to communicate in this ad hoc network. Wi-Fi is the most promising wireless technology because it is unlicensed and free of charge. And Wi-Fi already deploy ad hoc network function that is called Easy Mesh. We can buy Easy Mesh products in the market, current market. Ad hoc network, the end of ad hoc network may connect to a Wi-Fi access point, AP. Then AP connects ad hoc network to the internet. So out of the 5G cover area, we can use Wi-Fi ad hoc network to get the high speed network to the internet. So it's very important to keep with the communication quality to be high. This means that Wi-Fi quality of service such as throughput must be higher. So far, many efforts are devoted for improving Wi-Fi quality of service, QoS. most of them are technology based on network control. Of course, a network carrier should manage its network and its network performance. However, if they invest more into their network to improve the QoS, network cost increases, and the increased cost is charged to end users. So we thought higher quality result in higher fee. However, end user want not high monthly fee, but low one. So now we should seek another approach. The approach should meet both requirements, easy to be implemented, and less cost to network provider. The idea to achieve these two is user and network cooperation. Now, let us think again. Who should improve network quality? What do you think if user can improve network quality? Or user can contribute to improve network quality? If human or machine mobility improve network quality, it results in higher quality but no monthly charge increase. This mechanism is explained as the same analogy of full service restaurant or self-service restaurant. The important thing is we can choose full or self-service restaurant. So far, we have to choose only full service in a network service. But now we will have a choice of self-service. User cooperative mobility is very simple and easy idea. If two users communicate in wireless like this, well, okay, they can improve their quality, but by coming close to each other. This is true by nature of wireless radio signal that is decreasing with distance. So they come close, the signal becomes stronger, and the quality get improved. So this means just move to improve quality. It's very easy control and very it is very easy control and very obvious control. So you may ask me, is this a novel idea or you do not invent this? Yes, they are true. I don't invent this mechanism. However, we should research this control more and more. Let us imagine if two guys come close 5 meters from here and they get 1% quality improvement. For example, 10 megabps throughput becomes 10.1 megabit per second. Is this happy on them? No. But if you provide 5 meter move and get 1% improvement, do you want to move? However, if 5 meter move brings 50% improvement, for example, the throughput becomes 15 megabit per second from 10 megabit per second. The two guys may want to move. So the performance is very important, and to estimate the result of the improvement is very important. So the research should be done for how much improvement we can expect to a specific movement. So we can avoid network operator investment by simply user movement and can get more throughput without additional cost. Now, I guess you are thinking about user costs. Movement can be cost, can be? Yes. User movement is a cost, and the cost depends on many factors, such as individual utility functions. Maybe I can move easily, but you can not. So it depends on the users and the condition. If I'm doing some work in rush, maybe I want to get more throughput, so I can move. But now I watch YouTube, so I don't care. So the condition different, the cost is different. Okay, and time, place, etc. Okay, those are factors of the user's cost, but it's very independent on human by human or machine by machine. Okay, so this research should not consider the cost but consider performance. Then, if the performance is provided, such as 5-meter move brings 50% improvement. If user take or not take, it's up to the user. If user want, user move. If user don't want to move, so to take need the improvement, the user don't take. Okay. Now let us look at some example. This is an example to show how several different movements affect on performance. This is a very simple model and only consider MAC layer. We don't assume collision in this Wi-Fi network. The user A are connected to access point, then the user B and C is connected to user A, and user D connected to user C. This is ad hoc network and share the same bandwidth. So by the CSMSCA, the random access model, if A, B, C, D have the same length of packet, okay, likely the 1,500, 1,500 byte packet. Okay. This figure shows the transfer time. Okay. So the user A, B, and D send their packet very short time because the distance between them are very small. Okay. But the distance between the A and C is very large. So the A and link between A and C is slow. So the C take more time to send his packet, even that they all send the same length of the packet. Okay. So in this time unit, they send 4 packets. Okay, so the throughput is 4 packets. Okay. Then if C move from here to here, because the link between the A and B is very long. So to short the link, the C move from here to here. Okay. So the result is here. Okay. But now look at what they sent. It's A sent packet, B sent packet, C sent packet, D sent packet. Okay. C can smaller the packet. No, sorry. C can smaller the sending time of his packet, but the D, the packet time, sending time become longer because because C move from here to here, so the length of between C and D becomes longer. Okay. So compare after and before and after. So the before and after, the link size is changed, but the throughput is the same because the before the movement, the 4 packets is a throughput, but after the same, the 4 packet is the same throughput. So throughput does not change in this system. Even the user movement. Then if in this model, if D move from here to here, move to the middle of the between A and C. So the network changes like this. Okay. In this case, the C link between C and D link between A and D is smaller, becomes smaller. So the compare the before and after. The before we have only 4 packets, but now we can send 6 packets. Okay, the throughput improved 50%. Okay, this is the effect of the result of the user cooperative movement. Okay, let's go to another example. Okay, in this example, we consider a little bit about the physical layer effect. Okay. Now, we assume this network model. The Bob is connected to AP, and Alice is connected to Bob, and Charlie connected to Alice. Okay. And maybe the leads of the intimacy or the relation of the friendship, the Bob cannot connect to Charlie. Okay. In this case, this is the result. Now the Bob and Charlie is fixed, so they don't move. But Alice can move. And the colored map is the heat map. And the color means the throughput after Alice is going to that position. Okay. So now Alice, if Alice does not move, the Alice color may be the red. Okay. So maybe Alice has this throughput, very high throughput. And if Alice want to move to close to Bob, the throughput of the system is going down, decreased. Okay. So maybe the intuitive case, maybe Alice should move between the Bob and Charlie, maybe in the middle of the Bob and Charlie. But if Alice move from here to here, the throughput is decreased. Okay. Then look at another example. Okay. Look at the left side figure. In this case, if Alice go close to Bob, the throughput is increased. Okay. So compared with the last one I'm explaining, the Alice should not go close to Bob. Okay. The difference of the right figure and the left figure is the place of the access point. In the left side figure, the access point is very far from Bob. So the system total throughput is lower than right side model. Okay. But in the left side model, the Bob used the very slow link between the Bob and access point. So it is stronger. It is very strong to the interference. Okay. Interference signal. Okay. But in the right figure, the Bob is very close to access point. So Bob uses the very high speed transmission rate. And the high speed transmission rate is weak against the interference. Okay. So in this case, if Alice come close to Bob, the Alice's interference effect on communication between Bob and access point. But in the left figure, the signal between Bob and access point is very strong. Signal is not strong, but the signal is very tolerant against the interference. So the Alice should come close to Bob. Okay. So the very small difference between the right figure and left figure, but the where to move to improve the throughput is very different. This is the case. Okay. So the user cooperative mobility is very useful, but we have to investigate such model and relation between the model and the performance more. So I summarize my talk. The user cooperative mobility is very useful and very effective and easy to implement. We don't use the software modification, hardware modification, and carrier doesn't invest something to their network. So it results in inexpensive, but very effective, as we see. This is my presentation. Thank you for attention.
Okay, thank you for Professor Ross's speech. And let us go to the next speaker. And Professor Joe Fell, can you hold the next introduction?
Sure. Thank you, Dixon. Thank you, everyone, for being with us today. And yeah, so I'm actually from South Australia. It's midnight, but I'm getting warmed up by very interesting talks that we are having tonight. And now it's our pleasure to have Dr. Surena Merat from Canada to present his distinguished talk. Dr. Merat has been very kind to us to accept this invitation and deliver his insights. So without further ado, I would like to invite Dr. Merat to share his screen. Dr. Merat, is it okay if you could share your screen and start your talk? Or perhaps I leave it to you to introduce yourself. I know you have lots of credentials. You can introduce yourself better than I can do.
Exactly. Thank you so much. Thanks everyone for attending today's presentation. Let me share my slides here. Okay. Can everyone see the slides?
Oh, yes.
Okay. All right, so thanks everyone for joining. For my bio, there's not much to say. I do some research in intersection of the human behaviors bioneuroscience, and cyber social engineering, try to find some solutions to stop social engineering attack by looking into deep into human behavior, bioneuroscience and stuff, and come up with some solutions. I've done the PhD Masters in University of Toronto. I have some background work with the Institute for Quantum Computing and Premier Institute for Physics at Waterloo, Ontario. And currently, I'm in the industry and lecturing part-time. I don't hold any university position at the time. So that's for that. For the presentation, I know that I don't have a lot of time and try to be quick on the slides. But before we get into the slides, let me give you a very quick pre-job before we get into the slides. The reason I'm giving this to you is because I may go over the slides very fast, and I just need to give you an idea of what I am talking about over the slides. So, but we all know what is the social engineering these days. Social engineering means people trying to use the weakness of human behavior on social platforms and design an attack and compromise your personal data and stuff like that. So what is going on today to stop that is more and more company and organizations, they adopt models like machine learning models, AI models to recognize the attacks and attackers in the early phases of the attack, like the reconnaissance phase and stuff like that, and stop it. Now, the problem is that those models today, they work hand to hand with the human oversight or human intervention, or on a higher level, those models are designed based on human-centric items and requirements. So they're hand in hand with the human. So saying that, those models, they have some weakness overlap with the human. So for example, when a attacker find a human weakness, they most probably can find an overlap weakness between the human and the model and use that as an attack tunnel or attack path. Then that comes with a new issue in the model board called the adversarial attack. So the attacker can design an attack for human and can then design an attack for the overlap of a human and a machine. So they can fool the models like a machine learning and AI model as well, and become a larger attack to companies and organization compromising data. So I'm trying to go through this very quickly, and then at the end I can answer some questions. The title of a talk is Social Engineering, Future of Advanced Technology. In the last two slides, we get into the future of like quantum machines, quantum computers, and how the quantum computers are removing or eliminating all we know today as encryption, which is the encryption is the best we can do today to secure ourselves, and the quantum computers are removing those altogether. So does anyone know how to get rid of this thing? Or maybe this. Okay, all right. Okay, so going through the introduction of a social engineering cyber defense algorithm, issues with that today is like social engineering attacks, manipulating people online to gain access to the sensitive data. And those are designed highly dimensional, like they're attacking in a many dimension of the personal availability online on the social platforms to gain access. And there are many variable features for the defense algorithm, which we go to the next slide to learn how to defend those social attacks. Problem with that is the data comes from personal side, the user side. For the model to learn how to defend, those data are like often too noisy, and filtering those are very expensive and very difficult to make a clean data understandable for the model to learn human behavior and defend human on the social platform. It's very difficult for defense algorithm to learn, and filtering is too expensive, too time consuming, labor intensive. For the defense algorithm, the landscape of a defense is constantly evolving. New attacks are coming to the game, can make it difficult for defense algorithm to cope up with the new attacks coming to the game. And the problem is every day they have to create a new algorithm because the yesterday algorithm probably not too efficient. And that new algorithm must go through the cycle again, learn noisy data, and then cope up with the outside world when the attackers are outside to put up an adversarial attack. Well, now here is what I was talking about, the overlap of the human and the machine. Like the new algorithm, defense algorithm, they must learn the overlaps. They must learn overlaps from those noisy data and from the attack information that we have from outside, and then act fast. The covert method can really compromise and challenge models and the human behavior altogether. There are so many factors and parameters which is outside of this presentation to explain how a covert attack can be efficiently compromising model and a human both together. Adversarial attack is an attack designed specifically to use the machine learning model and fool machine learning model. Meaning that, for example, I'll give you an example. Like when you watch a fake video, deep fake video, the human believe it, and human intervention to machine learning model can make the model also believe it. And then that becomes a open channel for the attacker to use and attack both human weakness and the machine weakness at the same time. Example is stop sign for a self-driving car. If the self-driving car know how to detect in a stop sign, this is a classical example, like a very classic example. If they put a stop sign slightly in an angle, or just put some stickers, random stickers on the stop sign, that can actually detect one of the classical weakness of the self-driving car ML algorithm. The machine can easily fool with the sign and see the stop sign as another sign. This is just a classical example of how the adversarial attack can be designed to compromise machine learning model, defensive machine learning model. And then the model can make an incorrect decision at the moment, which is, as I said, very fast. Like there is a very short period of a time that model can make a decision to stop the attack, and then it can make an incorrect decision. So now here is no big issue out there in industry, like organizations and the companies and the states and the countries who try to limit the internet access out there by throttling the bandwidth, by blocking the website, by this and that. Those attempts to limiting internet can actually be seen by ML model as a problem in the connection, like a denial of service or a DDoS or things like that. Or if they're using the MLS and QMLS and the stuff, that MPLS, that can be one of the issues related to that. And model can see that as a problem in the connection, and that can be actually used as a deficiency of the model to learn how to defend because the data is incompatible or insufficient, and then ML model, defensive model become attackable or become more prone to attack. So go over these quickly. Well, when they throttle the bandwidth, selective blocking website and services, the disruption of the protocol create a network traffic pattern, which is very similar to denial of service, DOS or DDoS. Well, that model can be used to hide a real attack behind that deficiency data model. Limited internet access can act as a smoky screen. And then the training data can be biased by those limitations. Learn to consider this limitation as normal when they are not normal. And then in a normal situation, the machine learning, defense learning cannot act normal, which is now as abnormal, according to the training data. And then it can impact on the effectiveness of the defense mechanism. For example, security updates, threat intelligence feed, communication with external security services might be disrupted, weakening the overall security posture. Again, I'm going very quick over these because time is limited. I hope it's not too confusing, but I can answer if there's any question at the end. Well, some of the challenges defending against adversarial attack. Adversarial effect is really difficult to detect because algorithm has layers like a bacon is sleep, hidden layers, all the layers to detect a object. If all through the layers cannot be detected, it becomes really challenging to detect after that. In 2017, researchers tricked the Google image classifier into identifying a panda as a gibbon by adding a small, carefully crafted postulation to the image. And it can be difficult to develop effective defense against that because that the adversarial attack, all the detection is going to be used as a training data in the future, where the AI model is fed adversarial examples during the training process to make it not to detect adversarial attack as a normal situation, which is going to be very difficult. This is a continuing of the challenges defending the adversarial attack. Again, the training a machine learning algorithm is going to be too difficult. And defense distillation to make it more viable, readable, understandable for the machine. It is going to be very difficult too. And validation of the training input data is going to be extremely difficult. Again, we are talking about an ocean of data, lots of noises, lots of other stuff, and anomaly detection on that is very time consuming and very expensive. Well, okay, so future of quantum computers. As all we know, the quantum computers are coming up. Every day they're making a new progress. Google just announced a 110 or I don't know 115 qubit quantum computer commercialized, probably sometime in this year, next year, ready for the market. And all we know, the quantum computers are going to break all we know as encryption today. As you all know, encryption is best we can do today to securing ourselves for both data at rest or data on transmission. Both of those, all we do today, our best is to encrypt. Well, we have other stuff like physical logical barriers and all of those stuff, but the best we can do is encryption. Quantum computers are going to break that, and quantum computer is actually going to be used on both sides, like a dual edge technique or dual edge industry. What does that mean? Is like quantum computer can be used in attack side and defense side. So we both can utilize quantum computer, an attacker and a defender. Now, interaction of quantum computer and human is a question, still a question. And how quantum computer can cope up with the attack quantum computer, that's another question. Those are the big questions up on the air, and probably for the future to answer those. I am very interested answering these questions. If anyone on the call is doing some researches in this area, would be very happy to listen to them, or if they have any course or any presentation, would be more than happy to attend. This is just a high level, a few example of some algorithms being used today. Shor algorithms, all we know is like a very well known Peter Shor algorithm is now being tested for RSA encryption, both for public key and private key and all of those stuff. Shor algorithm is showing a very good progress these days on that area, and is breaking encryption methods back and forth. Even with the 110 qubit computer, it's still showing a extraordinary progress and efficiency. And the Groove's algorithm as well is showing a promising efficiency in password breaks and access lists, rule-based connections and stuff. Groover algorithm is really showing good progress on that area. That's it. All back to you, Ali. Thank you.
Thank you very much, Serena, for very interesting and enlightening talk. We all learned a lot about your talk. Do we have any question from Dr. Meras from our audience here? Or from yeah? So perhaps I can ask myself. You actually touched a very important area of social engineering related to quantum computing. Is that right?
Right. Yeah.
So what could be the example related to a cyber attack that could potentially happen in the area of quantum computers?
So there is no because quantum computers way to go. They're not really commercialized. There's no real example, like a real world example. But speculation on the issue is we have human operator of a system. They are fully trained. They've gone through all the trainings. Trainings are every week, for say, every month, every 6 months. They know what is the attack. They're trained to detect an attack. They're trained to defend the attack. On the top of that, we have the organization with the emergency response team. They know if the attack happens, if something is compromised, what to do to protect it, to box it up, this and that. And in frontline, we have models like AI, machine learning models, which is designed for defense. But on the top of all of those, what we do, for example, we do encryption. So because there are times that people are not in the office, no one is in the office, or they are back home, office is closed, and we still have, even those hours, we still have valuable data to protect. Those called data at rest, because data is resting at the server, is not on transmission, is not on the line, is not on the email, is not on the wires. So for that data at rest, we use encryption. As soon as data goes to the OneDrive, to the server, we do encryption. Now, when the quantum computer comes, encryption is compromised, badly compromised. And our data at rest with encrypted method, whatever it is, 128 bits of encryption, whatever complicated encryption, is not going to be safe, as well as data on transmission, which is encrypted as well. Those are not safe as well. So I try to raise the question for the thinkers, what would be the next when the quantum computer is commercialized? People are working on it already, like the U.S. Department of Defense, DoD, put a bill out there years ago that every design must be quantum proof, they call it. So I know that they're working on it and they're spending a lot of money on it, but for our people out there, researchers, without access to that confidential data. So we need to think about it. When the quantum computer is commercialized, we know that no encryption is safe anymore. We know that machine learnings are not helping anymore unless we wait a few years. Then the machine learning algorithm, which is quantum computer compatible, or out there, then probably algorithm can back into the role again. Well, we all know that for a while everything is unsafe. Then what we should do? We probably can think about something else. You know what I mean?
Oh yeah, thank you very much, Serena, for sharing your insights and interesting examples that you've shared with us. I don't have any further questions, so I perhaps leave it to Fabrizio. I guess he wants to conclude the session. Thank you, Suren, for your interesting talk.
Sorry.
And thank you, everyone, for being with us.
My pleasure.
Thanks.
Sorry.
Thanks,
Sorry.
Dixon.
Yes, I have questions to Professor Mera's speech. So my question is that, as we know, Elon Musk have launched several low Earth orbit satellites for the communications. And so my question is that for low Earth orbit satellites communications, will the QoS control will be significantly impacted, your proposed user cooperative mobility will be significantly impacted as well?
So
Thank you, Dixon.
is it for me
I
or?
think the satellite communication, is covered very wide area, but it is very shared very many people. Okay, so the throughput per person is very low. So, so I think it maybe the complement of the cellular or the Wi-Fi communication and I think the user cooperative moving still effective, such as the in the area where the satellite communication does not reach, such as the underground or the forest or the some other hidden area. And it is. And now I'm now investigating the forest internet. In the forest internet, many trees block the signal from the satellite, so we cannot use the satellite communication. So in such area, the user cooperative mobility, that's the idea of the concept of the user cooperative mobility is very important, because it's a forest area. We have very few people, so we can not connect human by human, not so easy. But the machine instead of the human, like the UAV drone, can be replaced with the human, and drone and UAV can form the ad hoc network, and the same concept of the user mobility can be applied to it.
Okay.
Thank you. Thank you.
Thank you.
Thank you very much. I think we are running out of time. I don't know if David had a question or.
Yeah, just a very quick question for Professor Muraise. I was just wondering if there is an optimal steady state for the movement in the mobility algorithm that you have. So, or is it a case that everyone has to continuously move and adjust, or how does your system or your solution find the optimal positioning and then people stay stationary? Just curious about that.
Well, thank you for your question. It's a very important and a good question. And yes, so it's very difficult to answer. And now I am investigating such a scenario. We have many nodes, ad hoc network nodes, and some of them can move, and some of them cannot move. Okay, maybe the situation which one can be moved, which one cannot be moved. The result is different. Okay, so in another aspect, the solution is if they can all move at the same time, or they move one by one, that maybe the solution of the optimal solution can be different. Yes, so it's very difficult to answer, and now I'm investigating. So thank you very much for your good question.
Thank you.
I think there is another question by Joao, who raised his hand. Please.
Yes, good morning, good afternoon, good evening, everyone. My question is for Professor Murase Sensei. I would like to ask if Professor Murase Sensei saw the post Elon Musk made today on X, saying that they are starting the beta phase of Starlink project, which is to connect a smartphone directly to Starlink satellites. According to the post, it seems that it's gonna be possible to connect our smartphones directly to Starlink satellites, regardless of where we are. If we are inside the building, if we are in the forest. So I would just like to know what are the Professor Murase thoughts about this, if it's gonna come soon, like next year, or maybe after 5 years. Thank you.
Yeah, thank you for your question. I think the satellite communication is very useful, but you know the Starlink antenna receiver is very large. It's a kind of the so we cannot take the antenna to my backpack rucksack. It's very large because the satellite radio signal is very weak, so we have to concentrate the signal by the such big antenna. Okay, so I think yeah, it's very maybe it takes some time to make the small antenna in a smartphone. Okay, then the next problem is the satellite antenna. The current satellite antenna is fixed, but the smartphone is not fixed, but fluctuated in its direction or the phase or something. Okay, so it's another difficulty to receive the signal. Okay, and even if the antenna is provided in a smartphone, the as I said, the signal is very weak. So if the something in the sky, they block the signal. So in my experiment in a forest, the only one branch of the tree broke the Starlink signal. So we cannot use the Starlink in a forest at all. But only we have some spot in a forest. So the spot is reserved not to grow the trees. So in that spot we can receive the Starlink satellite signal and communicate via Starlink. So that we set to the Starlink antenna such a point, then take the ad hoc network, the multi-hop network to the destination. We are thinking such application, and we hope we can use the satellite communication in our smartphone. Thank you.
So I think that we received many interesting questions, and I second David's comment. We had very nice speeches today. So I want to thank again Alireza and Dixon, who with their technical committees invited these two great speakers. I want to thank again the speakers. Really appreciate your time and dedication to these talks. I want to thank all the attendees. So please stay tuned on the web page of the technical committees. The date and speakers of the new webinar will be announced soon. Thanks again. Bye-bye.
Have a good
Thank
day.
you.
Bye bye.
everyone.
See you.
Bye-bye.
Bye bye.
Thank you.
Bye bye.
Bye.
Bye-bye.